म चाहिँ बीएससी फर्स्ट इयर फिजिक्सको हिट एन्ड थर्मोडाइनामिकबाट चाहिँ एब्सोल्युट स्केल अफ टेम्परेचरबाट चाहिँ नोट लिएर आएको छु। यो भिडियो चाहिँ स्किप नगरेर चाहिँ हेरेर चाहिँ नोटहरू चाहिँ कपी गर्नु होला। एब्सोल्युट स्केल अफ टेम्परेचर according to the Gardner theorem, the efficiency of a reversible engine is independent of the working substance and depend only on the two temperature between which it is working. Lord Kelvin had made his reference and defined the temperature scale, which does not depend upon the properties of any particular substance. This is the Kelvin absolute thermodynamic scale of temperature. Let us consider for reversible cycle in which Q1 amount of heat is absorbed at temperature Q1 and Q2 amount of heat is released at temperature Q2. Now efficiency of the engine eta equal to 1 minus Q2 divided by Q1 equal to F theta 1 comma theta 2. Q2 divided Q1 equal to 1 minus F theta 1 comma theta 2. Q1 divided by Q2 equal to 1 divided by 1 minus F theta 1 comma theta 2 equal to F theta 1 comma theta 2. This is equation 1, where f theta 1 comma theta 2 is another function of temperature. Again, if Q2 be the amount of heat absorbed at temperature theta 2 and Q2 be the amount of heat absorbed at temperature theta 3. Q2 divided by Q3 equal to f theta 2 comma theta 3. Let equation number 2. If Q1 be the amount of heat absorbed at temperature theta 1 and theta 3 be the amount of heat absorbed at temperature theta 3. Q1 divided by Q3 equal to F theta 1 comma theta 3. Let equation number 3. Multiplying equation 1 and equation 3, we get Q1 divided by Q2 multiply Q2 divided by Q3 equal to F theta 1 comma theta 2 into F theta 2 comma theta 3. Q1 divided by Q3 equal to F theta 1 comma theta 2 into F theta 2 comma theta 3. Q1 comma Q3 equal to F theta 1 comma theta 2 into F theta 2 comma theta 3. Equation number 4. This equation number 4 is the function equation. It does not contain theta 2 on left side, so to remove theta 2 from right side, let us consider another function as f theta 1 comma theta 2 equal to phi theta 1 divided by phi theta 2 and f theta 2 comma theta 3 equal to phi theta 2 divided by phi theta 3, where phi is another unknown function of temperature. F theta 1 comma theta 3 equal to phi theta 1 divided by phi theta 2 multiply phi theta 2 divided by phi theta 3 equal to phi theta 1 divided by phi theta 3. From equation first, theta 1 divided by theta 2 equal to f theta 1 comma theta 2 equal to phi theta 1 divided by theta 2. Since theta 1 is greater than theta 2 and Q1 is greater than Q2, so the function phi f1 is greater than phi f2. This phi theta is a linear function of theta and can be used to measure temperature. Let us suppose phi theta equal to tau on new scale, then Q1 divided by Q2 equal to tau 1 divided by tau 2. That is an equation 5th. This is equation 5th defines the Kelvin absolute thermodynamic scale of temperature. Thus, the ratio any two temperatures on this scale equal to the ratio of heat absorbed and reject by a Carnot reversible engine working between these two temperatures. Now, from equation 5th, we can write Q1 minus Q2 divided by Q1 equal to tau 1 minus tau 2 divided by tau 1, or W divided by Q1 equal to tau 1 minus tau 2 divided by tau 1. Thus, temperature on absolute scale can be measured in terms of work. So, this scale is also called work scale of temperature. र साथीहरु, अब हामीले चाहिँ क्वेशनहरु पनि हेरौँ है. So that negative temperature is not possible in absolute scale. There cannot be any temperature less than 0 or negative temperature is not possible on absolute scale. The negative temperature means that the heat engine absorbs heat from the sink and give back to source, which is against the second law of thermodynamics. To prove it, let tau 1 be the temperature of source on absolute scale and tau 2 be the temperature of sink on absolute scale. Let us assume tau 2 equal to minus K, then efficiency of Carnot engine is eta equal to 1 minus Q2 divided by q1, since q1 divided by q2 equal to tau 1 divided by tau 2 for absolute scale. Eta equal to 1 minus tau 2 divided by tau 1 equal to 1 plus k tau 1. Where eta is greater than 1, that is the efficiency of engine is greater than unity, which is against the second law of thermodynamics and hence impossible. Hence the negative temperature is not possible in absolute scale. Second question, so that absolute scale is identical to the perfect gas percent gas scale. The thermodynamic scale defined by utilizing the property of working of Carnot reversible engine, that is as function of temperature, is called absolute scale of temperature. It is independent of nature and properties of working substance but depend upon temperature between which working substance works. Lord Kelvin worked out the theory of such an absolute scale, so it is also called the Kelvin work on thermodynamical scale. Let us consider a reversible Carnot engine using perfect gas as a working substance. As perfect gas, let Q1 be the heat absorbed at temperature T1 from source and Q2 is the heat rejected at temperature T2 to the sink by working substance. Then the efficiency of Carnot's engine is eta equal to 1 minus q2 divided by q1 equal to 1 minus t2 divided by t1. That is an equivalent equation first. According to the theory of absolute scale, q1 divided by q2 equal to tau 1 divided by tau 2. That is an equation we can let here. Equation number second. Now the efficiency of the engine on absolute scale is eta equal to 1 minus q2 divided by q1 equal to 1 minus tau 2 divided by tau 1. Equation number third. From equation first and third we can write T1 divided by T2 equal to tau 1 divided by tau 2. Let equation number fourth. So the ratio of any two temperature on the thermodynamical scale is same as on the perfect gas scale. If T2 is equal to 0 in equation fourth, we get tau 2 equal to 0. So the indicate that 0 of absolute scale is identical with 0 of perfect gas scale. Now let's take the temperature limit, steam point and ice point. Then on perfect scale, NV equal to 1 minus temperature at ice, temperature at steam. NV equal to T steam minus T ice divided by T steam. And NP, that is NP equal to 100 by T steam. That is an equation fifth. Again in absolute scale we can Na equal to 1 minus tau ice divided by tau steam, or Nu equal to tau steam minus tau ice divided by tau steam. Since the efficiency must be same in either case, so from equation fifth and fourth we get Np equal to Na, that is 100 divided by T steam equal to 100 divided by T steam tau steam, T steam equal to tau steam. Similarly, T ice equal to tau ice. In general, temperature equal to tau. Therefore, Kelvin thermodynamical scale is identical with perfect gas scale. How is Kelvin scale realized in practice? The Kelvin absolute scale cannot be directly realized in practice. It is, however, exactly identical to an ideal gas scale. Hence, the temperature measured by a constant volume gas thermometer filled with an ideal gas would exactly be the same as the temperature measured on the absolute scale. But in practice, no gas is ideal. Hence, we can not have an ideal gas thermometer. However, the constant volume hydrogen thermometer, any reading taken on the hydrogen thermometer can be corrected to obtain on the ideal the corresponding reading on ideal gas thermometer. Thus, Kelvin absolute scale, which coincide with the ideal gas scale, is realized in practice. ल हस् त साथीहरू, आज चाहिँ हामी यहीँ लिएर चाहिँ रोक्छौँ. भोलि चाहिँ हामी इन्ट्रोपीबाट सुरु गर्छौँ.